and Engineering, and this seminar has been jointly organized by the Nuclear Science and Engineering Department and my team. And we're very fortunate to have with us today Bill Magwood, who is the Director General of the OECD Nuclear Energy Agency. Mr. Magwood has extensive experience in both the regulatory and the developmental aspects of nuclear energy. Before taking on his current role at the NEA, he served from 2010 to 2014 as one of the 5 commissioners appointed by the US President and confirmed by the Senate to the US Nuclear Regulatory Commission. And as a commissioner, he advocated for the importance of nuclear regulatory independence and the necessity of maintaining strong, credible, and technically sound nuclear regulation in the United States and in all countries that use nuclear power. Before that, from 1998 to 2005, Mr. Magwood is Director of Nuclear Energy at the US Department of Energy, and during his tenure, he launched several important initiatives, including the US Nuclear Power 2010 program and the Generation 4 International Forum, which I'm sure many of you are familiar with. In today's seminar, he's going to discuss the present state of global nuclear power and his view on where it can and should evolve. And he's also going to be telling us about a project that was recently launched at the NEA that's called Nuclear Innovation 2050. So please join me in welcoming our speaker.
Thank you. Can you hear me? In the back, can you hear me? Yes? Good. Excellent. It's good to be here again. I don't think I've been here in, what, maybe 2 years? I think was the last time I was here. Longer than that? I don't know. It seems like I've been to MIT a few times over the years, and my former colleague on the Nuclear Regulatory Commission, George Apostolakis, is actually quite irritated with you for inviting me instead of him. So I promised him I would greet you on his behalf and pass along a really bad joke that he told me, which was he was explaining that he met an engineer who was so dense that he bent light. That was a joke. So it's not my joke, it's his joke. My jokes are much better than that. But it's a pleasure to be here, and I'm looking forward to having a discussion. I've already met with several of the students, and some of which are here in the room today now, and we had a couple of good chats over the course of the day, and it's very impressive to hear about how the community here at MIT is thinking about nuclear in a very multidisciplinary fashion, and I think that's something that is necessary for the future of nuclear energy, and I'm going to talk a little bit about that. But to charge forward, instead of, I think what I'd like to do first is give you just a quick background on the Nuclear Energy Agency. Many of you have probably heard of the OECD. The NEA, which is under the umbrella of the OECD, actually predates the OECD. Originally, it was a post-World War II collection of European governments that wanted to cooperate together to take advantage of this interesting new technology called nuclear that was being developed under the auspices of the Atoms for Peace program and other activities. And the Europeans wanted to cooperate to deploy nuclear power plants and to take advantage of other aspects of nuclear technology. This organization grew quite rapidly from there. Eventually, the United States became a member, Canada, Mexico, Korea, Japan, Russia. Today we have 31 member countries representing the large majority of the installed nuclear capacity in the world, and really the most advanced of the nuclear infrastructures in the world. So our job is to foster cooperation among these advanced countries to try to solve difficult issues associated with nuclear power. The NEA operates principally through a series of standing technical committees, and this chart shows you what those committees are. And each of these committees works in areas such as nuclear safety, nuclear law, nuclear technology development, nuclear science, and other areas, radioactive waste, radiation protection. And the way we operate is we bring experts from member countries together to discuss a variety of issues. And each one of these committees has subsidiary bodies, and altogether there's about 75 different groups that meet under the auspices of the NEA on a regular basis, addressing a wide range of issues. And most of our work product is represented by reports which are made available on the NEA website free of charge. And I've actually brought not so much a report, but a brochure that we used during COP21. And so we had a booth in COP21 that inside the, is it the blue zone or the red zone? I think it was the blue zone. That was the good one, not the bad one. And we handed this out and explained to people a lot of things about nuclear power, and it was actually a quite useful exercise. So we have copies for you in the back. We also, in addition to that, operate what we call Secretariat Service Organizations. And some of these I think you're very familiar with, such as the Generation 4 International Forum is under the auspices of the NEA. You're very familiar with that. Countries working together to develop next generation nuclear technologies. MDEP, the Multinational Design Evaluation Program, is a collection of advanced country regulators who are working together to analyze different issues associated with the state-of-the-art designs, such as the AP1000, the EPR from Areva, the ABWR from Japan. So that group's been in existence for quite some time and made a lot of good progress. And the newest addition to our family is IFNIC, the International Framework on Nuclear Energy Cooperation, which was created about 6 or 7 years ago to bring developed countries and developing countries that have aspirations to build new nuclear power plants together to discuss a wide range of issues such as infrastructure issues, nuclear waste disposal, nuclear finance, and things of that nature. Also, the NEA is a place where countries come together to solve problems. So many of our activities revolve around what we call joint projects. And the joint projects we have currently about 21 in place right now are created by countries that are interested in solving very specific technical and scientific issues. These are not limited, none of these activities are limited to our member countries. Many of these involve countries such as China, UAE, and other countries because these are being done on a global basis. An example of the type of joint projects that we work on includes something we call BSEF, which is a project that was assembled in the aftermath of the Fukushima disaster to look at how good our severe accident codes are. You know, we have these severe accident codes we rely on for safety evaluations, but here was a case where we actually had a core melt accident. So the idea behind BSAF is to look at all our severe accident codes, compare them to the data that we have so far at Fukushima. And then also, there's a handshaking with this, to use the codes to try to help the Japanese figure out what may have actually happened inside the reactor core and how much ex-reactor material might have actually penetrated. So this is something that's been very interesting activity, very highly technical work that's being done by multiple countries. So obviously it's hard to have a conversation these days, even 5 years later, and not talk about what happened in Japan. And as I think the last time I was here, I spent a lot of time on this, so I don't want to repeat that. In fact, I think I used this exact same picture 5 years ago. This is probably one of the most telling pictures. And that's because it really has changed things a great deal. The way that many regulators look at nuclear power, even in the United States, has changed things dramatically. For example, before this accident, there was a very, very clear line between beyond design basis accidents and design basis accidents, and we regulated with that line in mind. That line is very, very blurred today, and it really has changed the psychology of regulatory work in the nuclear area, and also it changed the way we operate nuclear power plants. When the accident happened, countries came together and wanted to compare notes on what they'd learned. And as that process went on, the NEA decided to put out a report, this report, which captured some of the key lessons from the accident. This report came about a year after the accident. And some of them are quite obvious, but I think they're worth stating. I mean, one, for example, that was made very clear very soon after the accident was that NEA member countries felt very clearly that their plants were safe, that there was no reason to overreact to the accident, that the lessons from the accident show that there were very specific instances about elements to the accident, and that nuclear power plants were safe to continue operating and continue being built. And in the United States, for example, we followed that. In the United States, after the accident, we continued operating nuclear power plants, and in fact, relicensed Mark 1 BWR reactors after the accident, and also authorized the construction of the first new reactors in the generation in the US after the accident. So we believe that to be true. But that doesn't mean there weren't other lessons to learn. And one important lesson is to recognize that extreme events can have an impact on nuclear power plants. Now, we knew that. We certainly understood that all along. It was very much a part of our regulatory infrastructure in the US and in other countries to recognize that severe storms, earthquakes, floods could impact nuclear power plants. But I think that actually seeing it happen in Japan and seeing the aftermath made us focus on this in a more determined fashion, and therefore this was something that we were absorbing. Something else that we knew, but again, I think we keep relearning some lessons over and over again, is this, and that is that there is a very important human aspect. And this is one that is probably one of the most difficult to wrestle with, because everyone in this room understands nuclear technology very well. Everyone in this room could probably point to design enhancements that can be added to a nuclear power plant to make it safer, to make it more reliable, to make it more resilient. But making people more reliable and more resilient, that's much tougher to do. Things like safety culture, which we talk about very casually here, are very difficult concepts in some cultures. And so we're now spending a lot of time talking to people about how do we make that adjustment? How do we make sure that safety culture works around the world? And if there are aspects of a national culture that impinge on safety culture and make safety culture different, we need to adapt to that and to make sure that the safety of nuclear power plants continues to be very high. Because my feeling is that if you look back at all the major nuclear accidents that have happened in the world, there is a safety culture aspect to all of them. And unfortunately, I think if there is another nuclear accident, there will probably be a safety culture aspect of that as well. So we want to try to deal with this. So this report captured that, but 5 years later, we've looked at the situation again to see what we've accomplished. So there's a new report which is available again on our website that looks at 5 years after the accident. And what we did in this report was we didn't go back and look at the accident again. I think there's a lot of organizations that went and took exhaustive looks at exactly what happened and who did what and why they did what they did. What we wanted to do was we wanted to look at what have we done to make sure that this never happens again. And because of time is short, I won't go through each one of these, but there's a long list of things that countries have taken on, regulators have done, operators have done, to make sure that we've learned the lessons from the accident, to make sure that we make our plants more resilient. And the thing that I find interesting about this is this list, while not every country has done everything on the list, in broad terms, the response across the world has been very much the same. In whatever country you go to, you see the extra power systems, the extra mobile equipment, you see the training programs, you see communications equipment. We've learned the same lessons, and I think the basic lesson we learned was that operators have to be given the tools to be able to respond to the unexpected events that might occur. You can't predict everything that will happen in the future, but these enhancements will enable the operators of nuclear power plants around the world to respond to whatever does happen. And I think that was a very important lesson to learn. Nevertheless, and as you know, while we've learned these lessons and we've made these changes, there's some people who think that nuclear power remains too dangerous. And so, around the world, we've seen people protesting nuclear power, calling for plants to be shut down. And this is something that has had a big impact in some countries. Some countries have announced that they will phase out nuclear power very quickly. Other countries that were planning to build plants have now said they will not build plants. And I think even countries that are continuing on the course, they're finding conversations with their publics a lot more difficult than they were 5 years ago. This is a natural reaction from a major accident. I don't think it's unexpected. I do think, however, that in some cases, the reaction has been a lot more conservative and a lot more a lot more of an overreaction than has been necessary. But nevertheless, the reaction is what the reaction is, and we have to deal with it. Now, for some people, this means quite clearly that the nuclear age is coming to a close, and nuclear plants will not be allowed to operate. This is a cover that I like to point to because I think it captures the mood of the post-Fukushima era very accurately. The nuclear plants have had their chance. It's now considered old technology. It's time to move on to something else. And this is really kind of the philosophy you get from the media often and for many people. However, at the same time, that's not what's really happened. Now, this is actually from the World Nuclear Association, and I could quibble with a lot of the things that are on the chart, but I think it captures a very important story. If you look around the world and you ask the question, who is building plants, who is maintaining the status quo with nuclear plants, who is planning to build plants, you look around the world and you look at the greens and the blues for the most part, and you see that most of the world thinks that nuclear is expecting to either actively or expecting nuclear power to be a significant part of their power infrastructure going forward. So in a sense, not a lot has changed. If you look at the numbers of reactors under construction and under planning today, it's very similar to what it looked like before the accident. Some of the numbers have switched. In some countries they've gone down, in other countries they've gone up, but for the most part it's about the same. So really, you look globally, there really hasn't been a big impact on future nuclear power as a result of the accident. However, you do notice that if you look sort of in the middle of Europe, there's some green and some black up there. And really, but once you get outside the middle of Europe, the situation changes very dramatically. And as you go into Eastern Europe, you go into Asia, you go into the Middle East, you go into Africa, and there's a great deal of interest and even a lot of enthusiasm about building new nuclear power plants. Now, there's a lot of reasons for that, and I think the reasons are what they've always been. The nuclear power provides a long-term baseload power source that doesn't emit CO2 emissions, that is very reliable, and that once the plants are built, they will operate in a very stable way for a very long period of time. And that's something that a lot of countries find to be very advantageous. And for countries that worry about security of supply, nuclear also provides a very important solution for them. Now, that said, we've also been talking about climate change. And I mentioned that nuclear doesn't emit CO2 emissions. And this is a chart that shows something really interesting, which is, where does the carbon come from? Well, it comes from energy, for the most part. About 70% of total greenhouse gases come from energy production. And as you can see, the amount of CO2 emissions that are emitted really kind of has been continuing to grow over the course of time. There's been a few blips here and there, but for the most part, it's continued to grow and track very much with the growth of the global economy. And really, while there's been some detachment between growth and CO2 emissions, that's still the general pattern we see going forward. This is the problem if you're worried about climate change, obviously. So people want to try to get an adjustment to this. And if you try to think about this issue, you have to recognize that nuclear power already plays a very large role. In OECD countries, nuclear power is the largest source of non-emitting energy available. Globally, it's second only to hydro. So this is a significant part of where we are today. And I think many of you have seen this chart because this comes from our friends at the International Energy Agency that we work with very closely in many of our analyses. And this chart is a very interesting chart, and I like this chart because it shows a very important story. The first thing it shows, obviously, is that nuclear plays a big role in the scenario that IEA put together to look at, well, if you ask the question, if we really want to reduce CO2 emissions consistent with the 2 degrees C scenario, that's the scenario when world global temperatures rise only 2 degrees above pre-industrial levels, you can see that it requires a pretty big investment in nuclear. According to this analysis, we would have to have nuclear capacity increased by 2.3 times what it is today. That's a pretty significant building program. That's another 500 or so reactors more in operation than we have today. But it also shows something else that I think is the more important story, because whenever you see these projections from the economists, recognize that they're wrong. Economists are always wrong. Don't tell your friends in the economics department that is true. But what it does show is that under this analysis, you also need a pretty heroic contribution from wind, from solar, from CCS, and all these things have to work in order for this scenario to work. And at the same time, we're still expecting to see a significant increase in energy efficiency. So all these things have to happen in order to meet this 2 degrees C scenario. So what this chart tells you is this is really going to be hard. This is not going to be easy. If the world is really going to try to do this, then what happens if you take nuclear off this chart? If you take nuclear off this chart, then you need even more wind, even more solar, even more CCS. And taking options off the table is not a serious way to approach this issue.
So, is conservation part of this scenario at all?
Absolutely. If you notice, this assumes 25% increase, 25% of all CO2 reduction will come from it.
Efficiency, but that's meant to include.
That includes conservation. All right, so that's something that I think has to be taken into account as we go forward. Now, the truth is, however, we haven't really changed our behavior. There's been a lot of talk about responding to climate change, responding to reducing CO2 emissions, and while we've just seen the treaty or the agreement signed in Paris from COP21, if you look at the behavior on the ground, you see this, which is that fossil fuels are still by far where investment is going globally in terms of future energy supply. And these plants, which are being put in place today, will be in operation for decades unless they're turned off prematurely, which is very difficult to do. So this is something that shows we haven't changed our behavior yet, but if we're going to turn this curve, something has to happen. Now, how big is the nuclear answer to this today? Not very big. This chart shows what nuclear would have to be if you look at the projections on the end on the far end of this, where we would have the nuclear capacity would have to be building to meet the 2 degrees C scenario, and the purple line shows you that we're not exactly meeting those targets. So we're not anywhere close to building enough nuclear to offset to meet the targets that we would need to meet this scenario. So this is something that is of interest to us because we are building maybe 5 gigawatts of new nuclear a year. You would need 12 gigawatts to meet the scenarios, and we're nowhere near that. So working with the IEA, we performed an analysis last year, which I think most of you have seen, that came out in terms of this roadmap. And this roadmap was designed to try to look into this matter and answer questions about, well, what do we need to do to try to turn this situation around and put nuclear in a position to meet the 2 degrees C scenario? Well, a lot of recommendations came out of this, and I think there's nothing here that's really surprising to any of you. Government should recognize the value of low carbon capacity, i.e. there should be carbon taxes or some other method to encourage nuclear and renewables and more efficiency. R&D is needed to continue operating nuclear power plants in many countries. Again, all these are very familiar to you, but there's one I wanted to spend some time on because it comes up so often, and that is the last one. Establish policies and sites for long-term storage and disposal of nuclear waste. And this is one that comes up so frequently that I wanted to spend a little extra time on it because it also links to some other things I wanted to talk about. The nuclear waste issue is, I often sort of think about it as the original sin of nuclear power in a way. The fact it's the one thing that when you're talking to the public, it's very difficult to get a public agreement on what you're going to do with a waste form that'll be dangerous for so long, for hundreds of thousands of years. And the truth is that it isn't really something that we don't know how to deal with. As a matter of fact, when the nuclear age began, there was a very clear plan on what to do with nuclear waste. Everyone was going to reprocess it. Obviously, that's not quite how things went. So as a result, the public, I think, at large, believes that this is a huge problem. And politically, certainly it is. Technically, perhaps we have some confidence we can deal with it, but from a public perception standpoint, it's a big issue. So I run this experiment probably once every couple of years, and it's a very, very sophisticated experiment. I go to Google, and I put in the words nuclear waste and hit images and see what comes up. And you know, over the years, this image has been very popular. And I'm not entirely sure what this guy's doing, but it doesn't look like a particularly good idea, and I don't encourage him to keep doing it. But this guy comes up a lot. Now, the next image that comes up is also something that just never goes away, and you're very familiar with our friend Homer. He's very prevalent in this. Recently, I've seen a couple of new ones pop up. I have no idea what this is, but I'm sure it's from some protest or something, but this shows up. And here's one I like a lot, and it's a picture of a large field of nuclear waste, and the man is telling his son, one day, son, this will all be yours. So this is the image that pops up on Google, and I think this is a pretty good representation of what a lot of people think about nuclear waste. It's a big problem, it's going to be around for a long time, it's really dangerous, and it's out of control. And that is something that we have perpetuated through our failure politically in many countries to deal with this in an adequate fashion. However, there is some hope. And the hope is that there are countries that are dealing with the issue. As you can see in this chart, several countries, Finland, Sweden, Switzerland, and France in particular, have made very good progress in establishing repositories. They haven't formally established them yet, but they have identified sites. There's a lot of very important work going on. They've used public consensus processes to try to narrow the field down. And some of these processes have been going on for a long, long time. But they've made some very good progress, and I think that you will see one or two of these in a relatively near term, 2020, 2025. And once that's done, I think it will show other countries that yes, you can dispose of nuclear waste, yes, it is manageable, and you can get a political consensus around it. Now, it's interesting to note that most of the countries, not all of them, but most of the countries that are making progress in this area are Nordic countries. And it was I find it interesting because at the same time, and this was not done by us, this was done by a group called the World Value Survey, it asked a very simple question. Basically, it asked, can most people be trusted? And the survey shows that the Nordic countries scored very, very high on this chart. So in the Nordic countries, they trust what people say. They trust people to do the right thing. In a lot of other countries, and the U.S. is sort of in the middle there, you can see the scale slides down pretty far. And you can see when you get down here, people don't trust anything that the government or anyone else is saying. So this is a big problem for all of you, because the people that need to be trusted when you're talking about things like nuclear waste are in large part technologists. So if you don't believe what the technical experts are saying, you don't believe what the government is saying, you don't trust what the government is saying, you don't trust what the regulators are saying, how do you ever solve problems like nuclear waste? So I think the trust factor is one that I think the technology, the engineering community is going to have to find a way to remediate, because this is one of the reasons I think that we've had such difficulty in moving forward on this issue. Now, as I mentioned, I wanted to use the nuclear waste issue to talk about something a bit broader, and that is that if you look at as I mentioned earlier, if you look back in the future, in the past of nuclear power, it was always anticipated that we would be reprocessing this material, that we would be using technologies like Purex to make new fuel and to deal with nuclear waste in a closed fuel cycle. That's not what we've done, obviously. And during the last several years, the question has come up in the US and in other countries, should we use that technology here? And I'll tell you, the answer at the very highest levels of the United States government when the question was asked was no. That the proliferation aspects of today's reprocessing technology are such that the US should not pursue it. And that was made clear at a time when there was a lot of enthusiasm for nuclear technology, a lot of enthusiasm during the so-called nuclear renaissance. And so the question then shifted to what should we then be doing? Now, all of you are familiar with P&T type technologies, advanced recycling. And you know what the advantages are, so I won't spend a lot of time on this, but one thing about this I see is that if we ever do decide to recycle, we won't recycle necessarily because we're trying to get more energy value out of nuclear nuclear fuel, it'll be because it's part of a waste management strategy. And the beauty of this type of technology, and this is charts that I think many of you have seen, anticipates the use of a fast reactor fuel cycle. If you can reduce the toxicity and the heat generation rates of nuclear waste so that you only have to store it for, say, a few thousand years instead of a few 100,000 years, you've changed the game when it comes to dealing with the nuclear waste question. However, around the world, there's very, very little work going on in this area. You know, when I was at the Department of Energy, we were just embarking on something called the Advanced Fuel Cycle Initiative, and we were looking at both aqueous technologies and also pyroprocessing as our base technologies. And there's a little bit of work going on, but it's very, very small scale. So we've made very little progress in this area in recent years. Similarly, we've made very little progress in Generation 4. And you're all familiar with this chart. You know, this is actually a chart that I did on the back of an envelope about 15 years ago, just for one presentation. It's proliferated. And I don't even know who did this version of it, but it hasn't changed much over the last 15 years. But it says basically the same thing, that we basically have this thought that the next step is before us, that we can develop reactors that are safer, more economic, that fit the markets more effectively, but you know, we're not doing enough work in this area. And I think that that's something that that people in this room are concerned about, that we aren't making the investments as a country, as a society, to really pave the way for the future. And that's something I've often been concerned about, because I think I for one think the future is important. And you know, a long time ago, people felt that way all the time. I mean, that's one of the things I like to do. I visit some developing countries, and you see the enthusiasm that people have in talking about the future, talking about the next step in society, not just nuclear, but just in general. What's the next thing to make life better, to make life better for the next generation? And we used to be that way. We used to have things like this happen. I like this chart. This is really old, but it shows two people, Glenn Seaborg, who all of you know, and James Webb, who was the director of NASA back in 1961. And this picture was taken when these two gentlemen were signing an agreement for the Atomic Energy Commission and NASA to work together on space nuclear systems. This is very future-oriented. You know, this was back when there was no limit to what we could accomplish if we just put our minds to it. Now, not much came out of this in the end. We did do some research. There was a lot of money spent on NERVA and other nuclear rocket technology, but we haven't made it to Mars yet, which has got me kind of depressed, but there's still hope, I suppose. Anyone want to sign up to go that one-way trip to Mars? Yeah, I didn't think so. Yeah, I think we'd like to bring people back, wouldn't we? So this is a picture that reminds me of what we used to do. And so one of the things that I am trying to do is to get people to think about the future again. And that is why we've started this, Nuclear Innovation 2050. Nuclear Innovation 2050 is an attempt to do something that's actually pretty straightforward. We're trying to get countries to look at nuclear R&D again. Many of them have small programs underway, but they aren't really directed towards doing big things. So we've asked a question. So we've talked about this 2050 timeframe. We want to reduce CO2 emissions. And if you go past 2050 and think about what the IPCC has said, they want to see CO2 eliminated entirely from our emissions profile by the end of the century. So how are we going to do that? How are we going to take CO2? How are we going to decarbonize our energy infrastructure entirely? And as we answer that question, what is the role of nuclear power? So this project is designed to answer that question, to get the world to come together on a research and development agenda, highlighting the need for nuclear power to play a role in this long-term future. So this work is already underway. We've broken the work up into 4 major sections. I won't go through this in any great detail. There shouldn't be any surprises here, but it does cover reactor technology, both near-term and long-term, as long-term operation. It covers fuel cycle and fuel, everything from advanced minor actinide fuels to accident-tolerant fuels for today's reactors. It covers waste and decommissioning, looking at how to dispose of waste products. So it does look at things like high-level waste repositories, and it looks at decommissioning, which I think is a very important piece of this, because if we don't look at technologies to make decommissioning more efficient, we could spend billions and billions of dollars decommissioning nuclear power plants that could be used for something more fruitful. And also we're looking at emerging at new energy systems, hybrid energy systems, hydrogen, things like that. So we have people who are working right now on this. Scientists from around the world have gathered under the auspices of the NEA to talk this through. And our methodology largely is not to try to recreate the wheel. There's a lot of good roadmaps. For example, Generation 4 International Forum has a roadmap that they've developed. So we're pulling all those roadmaps in from different countries, the European Union, or people from around the world, to try to find out where can we reach agreement on what this agenda should be. Where do we need to be, and what are the gaps? And let's identify the gaps so that we can identify areas where we should be focusing together, either on a multilateral basis or at least identify those parts of the programs in national governments and national programs that deserve more attention. So as I said, this work is already underway. In the last few weeks, we've had several of the groups meeting to try to chew through this. It's proven to be a very complicated exercise, but it's something that I think everyone has found very rewarding. We still have the emerging energy systems work to do ahead of us. But our hope is to be able to get this underway such that we'll be in a position to try to reach the final resolution about the middle of next year. This is a chart that my staff likes. I personally don't like, but it's the only one we have that describes the timeline. As you can see, the road mapping work is underway today, and this will go on really towards the end of the year. At some point, we're going to have what we call a lab summit, where we're going to invite leaders from laboratories from around the world to kind of take a snapshot look at where we are to see if we've missed anything critical. And then at the end of the whole thing, there'll be some kind of colloquium or something to go over this. But the real objective here is not to have a meeting, but to have an agreed roadmap, an agreed set of R&D priorities that everyone, or at least largely, can agree to. And that's something that, if we're successful, it should help us formulate really a global agenda that will help promote nuclear R&D. Now, this is all well and good, but often people ask me the question very bluntly, well, that's nice if you do this, but who's actually going to do this? Because a lot of your experienced scientists are starting to reach retirement age. And that's something that I think the US is actually a bit fortunate with this, because I think we did make investments in education at the right time. So we have some people who are in the pipeline. In some countries, it's not quite as good. I use this. I actually had pictures of some old scientists, but I decided it wouldn't be politically correct to show them, because you might recognize some of them. So I have this old picture taken from some nuclear scientists back in the 60s. But this is a big issue for us. This is a significant problem in a lot of countries. I visited several countries over the last year. They're very, very concerned that they don't have enough scientists and engineers in the pipeline to replace the people who are retiring. And something that's a very important nuance, and I think everyone in this room recognizes this, that a lot of the most experienced people are the people who were involved in programs that largely were in the 60s and 70s, were back when countries like the US were building demonstration projects, doing large-scale experiments, doing experiments in things like severe accidents. We stopped doing experiments like that in this country back in about the 1990s, and really haven't done much of that way since. So if you were a scientist that just started work in the 1990s, you didn't have a chance to participate in those experiments. So the people who have that experience are now leaving the field. So what we have proposed to do is something called NEST, the NEA Education, Skills, and Technology Program. And quite simply, what this program is an attempt to encourage more people to come into the nuclear research arena. We hope to do this in a multidisciplinary fashion, so this won't just involve nuclear engineers, but also people with a wide range of backgrounds in nanotechnology or computation or other areas that could be of benefit to solving nuclear energy problems. The way this will work is that we would have joint projects. I mentioned we do joint projects in the auspices of the NEA, and our hope is that we will be able to launch projects where where countries, say 3 or 4 or 5 countries will work together, and instead of having the work done at national laboratories or industry, we want to see the work done largely at universities involving students and involving young researchers. And so our hope is to use this to galvanize, particularly in countries that are having infrastructure issues. A good example is Italy. I visited Italy. They're very interested in things like this. The UK, which is trying to rebuild its infrastructure, would like to have participation in this. So we're talking to a variety of countries, and we're hoping to be able to launch this effort quite soon, perhaps in time for some kind of application process in the fall. So this is something that we're currently working on and hoping to get, this is the sort of the propaganda page, I guess, but hoping to get moving. And hopefully, MIT will be one of the universities we'll be able to work with to make this go forward. So we're very excited by this. We think this is a unique approach to addressing the skills issue. And often people ask me about knowledge transfer, and I see these knowledge transfer activities that go on where experienced scientists do videotapes and tell stories about experiments they did a long time ago or experiences they had operating nuclear power plants back in the 60s and 70s. And that's all well and good, but I'm absolutely convinced that the only way to transfer knowledge is to work together, is to have the students and young professionals working with people with experience who are there and know and have participated in large experiments and to work together for some number of years. So I think that's the only way this is going to work, so that's what we're trying to do. So with that, I will close and see if there's any questions. I think we still have, yes, we have plenty of time for questions. But our hope is to try to set an agenda for nuclear R&D going forward and to also take some steps to make sure that there are people around 20 years from now to make that agenda come to reality. So again, thank you very much. Let's see, I think you were first back in the back. Do you want to, should we use this because it might be, do you want to, is there, I don't know if there's somebody that can kind of pass this up there. Thank you.
Thank you. I was wondering when you mentioned that there's maybe a shortage of scientists in the future. I guess what kind of scientists are you looking for? Are you looking for the bachelor level scientists, master levels, or PhD level?
Well, I think the experience that I've seen around in the nuclear area is that there's really room for people at all those levels. There's just different jobs that need to be filled, different types of research that need to be done, and I think you'll see people at all those. Clearly, I think that this program is aimed more at people who are more likely going to be at the graduate level, but I do think that there's needs for people at all 3 levels. And there's also, in addition, continuing to be a need for people at the trade level, people who can be health physics technicians, for example, or maintenance operators and things like that. So there's lots of room for a lot of people in the field, and that's why, particularly in the United States, there's still a pretty active job market. Let's see, I think we'll take this one and then we'll get you.
I'm Shigata-san from Kyoto University, Japan. I have a question about Transmutation regarding their waste disposal and other things. Always about nuclear things, the rule for not in my backyard works. In Japan, many scholars or politicians say nuclear energy or nuclear waste is not so dangerous, it's safe, but not in Tokyo, but not in my backyard. In Fukushima or other areas, this rule not in my backyard is very decreases the trustness with these people, and politicians often try to solve the problem with money, but money is more worse. There is no real trustness with money. So how can we do with this problem? It's safe, but not in my backyard.
Yeah, that's a very good question. I think that if we all had that answer, we would have implemented it by now. I think it really gets to the core of the difficulty of dealing with nuclear waste. As you know, in the U.S., we had the Yucca Mountain project for a long time. It's very contentious. The administration has closed the program and wants to move on to a consent-based process. And the countries that have been successful have used consent-based processes, particularly the Nordic countries. However, I think that in a country as large and complex as the U.S., it's not clear yet whether that will work, and we'll have to see how it plays out. You know, they certainly plan to try it, but it might prove to be a very, very long process. And I know in Japan, very similar situation. They're trying to use consent-based processes to get communities to basically volunteer to do this. But they've also had lots of disappointments in Japan where they thought the communities were going to say yes, at least we're willing to think about it, and then when work started, they say, well, never mind, we don't want to do it. So it's a very difficult question, and I think that it does come down back to that trust issue. If people trust the institutions that make these calls on whether something is safe or not, I think it helps the process. But if they don't trust the regulator, they don't trust the government, they don't trust the industry, it's almost impossible. So I think that all those institutions have to build the level of trust that they have with the public in order to be able to move forward, because otherwise they'll continue to be stymied. So it's a very, very difficult issue, and I think it's a different problem in every country, but I think it does come down to trust. And money won't solve it, you're right.
Many of the prognostications, not least your own in AA, about scenarios 30 to 50 years hence, I think sometimes neglect something very important, and that is the current rate of climate change and the realization, even within the last year or so, that climates are changing much more quickly even than anticipated. Could it give rise to a very, very different scenario of needs? For example, the need for desalination in the wake of increased desertification of land might be very important, and that could have nuclear connotations in that, of course, there are already systems being developed for desalination using nuclear, potentially using nuclear energy. And it seems to me that maybe some even better crystal ball gazing might not only make the situation more clear and even more urgent, but also I think might point out avenues to move towards that might be more efficient in terms of utilization of energy for certain needs that will become much more apparent later on than now. Let me be the really unpleasant dark cynic for a moment. You know, I've spent a lot of time, you know, because the NEA is based in Paris, so I interact with a lot of European scientists and policymakers who spend a lot of time talking about these issues. It's actually very interesting. I come back to the U.S. very often to visit policymakers in Washington, and I've had trips where the word climate change never comes up. So you know, the perspective in the U.S. is very different from the perspective in Europe. But I think when you look overall, you see something that's actually kind of interesting, which is there are these different policy changes, such as the EPA rule that's being discussed today on clean energy. You see portfolio standards in some states to do more renewables. But when you think about those moves compared to the scale of what the climate scientists say is necessary, it's not even scratching the surface. And so as a dark cynic, I think I look at the situation and say, well, okay, if you're really serious about this, doesn't this require a much, much more massive mobilization of resources and research and investment than we're seeing today? And if you're serious about really solving this problem, wouldn't you see? I mean, think about it this way. When I think the last time that Western societies were very serious about a threat was the Cold War. And during the Cold War, think about the resources that went into building the national laboratory system. Think about the resources that went into the military. Think about everything from the highway system to the space program could be linked to the Cold War. There's nothing happening in the face of climate change that's even a fraction of that. So how serious are we? So if we're serious, we're not doing enough. And if we do enough, then issues like what you're talking about come into play. But we're never going to get there the way we're going. And I was at a conference where James Hansen, who sort of popularized this concept of climate change, was telling me that he was, how he came about this. He was just trying to test some of the technology they plan to use in Venus by looking at the Earth as a model, and discovered there was something going on. And so he gave his presentation, and he put up a slide with a black background that says renewables plus natural gas equals planetary doom. And so he said that's where we're going. And he said unless we change what we're doing, we're never going to be able to change the direction of climate change. And he's absolutely right, because we're not really taking it seriously in my view. But if we do, then the things you're talking about make complete sense. And by the way, I do think that there's some countries that will do desalinization anyway, because it's a good option for them with using nuclear systems.
Bill, I want to ask you a question about the future of the nuclear technology, about which you spoke a little bit in your talk. But first, I want to examine very, very briefly the history of nuclear technology. So it was developed in the 50s and in the 60s, essentially in the United States, also in parallel in Russia, that we certainly deny have access to that flavor of the technology. And during that period, it was sort of a very magmatic, creative period, through which we look at many different reactor types. Many were demonstrated and then down-selected to the light water reactor technology, and then that technology was licensed to other countries such as France, South Korea, Japan, and then they evolved their own flavor or their own approach, and now they're selling internationally. And if you look at the next generation of technologies, generation 4 and so on, non-light water reactors, it seems that China is likely to play the same role that the United States played 50 or 60 years ago. So I have two questions for you. First, China is not part of OECD, but what can NEA, which is part of OECD, falls under OECD, do to collaborate with China, really? And number two, what can we do collectively as nuclear community, not to repeat the same, in my opinion, error, to converge or down-select too quickly and lock ourselves into one technology, which at this point is PWRs and BWRs. Looking forward, how do we keep our options open for a little bit longer time?
Interesting questions. Well, first, looking at the history, it's something that I did in the context of a speech I was giving in the Nuclear Regulatory Commission several years ago. And I went back, and actually I think that's the first time I used this picture. Let's see if we can get back to it. Where's our friends from the past? There they are. So I think it's the first time I used this picture because just to understand the context, because we bemoan the state of nuclear R&D, but I went back and I looked at something that was actually proved to be quite interesting. I decided to look at both the AEC and NASA in parallel, and I kind of traced their progress, looking from about 1952, 1953 to the end of the 60s. So you kind of look at what's basically kind of a 15-year period. And for both organizations, it's actually pretty remarkable.
The AEC essentially developed commercial nuclear power, the whole infrastructure, as we know it today, in roughly 15 years. I mean, almost no time at all. NASA went from blowing up captured V-2 rockets on the ground to putting a man on the moon in 1969. I mean, it's when you think about it, it's kind of awe-inspiring that in 15 years these organizations could make that happen. And then you look in the succeeding 15 years, and you see where both organizations were changing, kind of resting on their laurels, kind of improving the technologies that they had. And then the 15 years after that, both of them kind of went in the reverse. And today, DOE isn't able to build much of anything, hasn't built anything in quite a long time. They'd like to, but they just don't seem to get a consensus to do it. And NASA can't get to its own space station. So you see that arc. And I think that comes back to what I was saying about the vision part of it. We don't look at the future as a place we want to be. We are so focused on maintaining the present that we don't put the investment and the energy into the future. And I think we all share some of the blame for not insisting that we make that investment for the long-term future, not just in nuclear, but really broadly in the technology areas. In some countries, this is the way they think. You go to China, and Chinese engineers are so excited about what they can do in the future. And there's other countries as well. You go to Korea, for example, and people talk very enthusiastically about the future, and that they want to see their country take these steps. And the Chinese are talking about building a space station, and then they're even having discussions about going to Mars. And if they want to do it, they'll probably do it. And I think that kind of enthusiasm is necessary if you're going to. It isn't just the money; it's got to be the enthusiasm. And we just don't seem to have that right now. And our leadership in the country for many years has been so focused on today that they don't talk enough about tomorrow. So I don't think it's just money. I don't think it's technical prowess. I think it's just the desire to have these steps taken in the long-term future. And I think that China and other countries do. And therefore, they will continue to progress until they reach where we are and get stagnant. Now, just to close out, NEA does work with China. China is a partner of ours. And I'm actually going to China Thursday. It's actually worse than it sounds. I get back to Paris Thursday morning. I leave for China Thursday night. So it's going to be an interesting week.
Good luck.
Yeah, thank you.
Yeah, I think energy, of course, is a very important part of the picture, but I think it's really one side of the coin, and that is, I think transportation is probably one of the biggest issues that has to be addressed. And I think the two have to be merged. And I certainly see that the hydrogen economy is one way to do it, where hydrogen is produced by MGMP, for example, high temperature gas reactors. And is this something going on that we are addressing also, in terms of coupling the two biggest energy issues?
It certainly is something I think will be captured in our NI 2050 discussion as part of emerging energy systems. I think hydrogen has to be part of that conversation. I guess it's now been about 10 years ago. We were working very ardently on hydrogen. And hydrogen seemed to be the answer. And I think that someone started to talk about how the difficulty of installing the infrastructure in hydrogen, and everything just kind of stopped. And I think that was a shame, because I actually do think that hydrogen answers a lot of the questions that we were posing at the time. But transportation has to be part of the picture. There's no question about that. And I think you're right. There has to be convergence here, because you can't really solve, if you're trying to solve climate change, you can't ignore the need for some kind of transportation link with non-emitting fuels. And I think that there's a lot of people that think you could just use renewables plus electric cars and you're good to go. And I think they're going to find you can't quite make that work. So I absolutely agree with your comment on that.
When you were mentioning the waste treatment and approaches and the fuel cycle issues, especially on the US problems that there is no real solution inside. One thing that I remind is that the only country really sticking to its gun right now is France, with that full approach of closed cycle, recycling, deep storage, repository. Is it what you think is a viable or a good approach, or how would you describe that strategy right now? Considering it's kind of the only country in the world sticking to that approach right now?
That's true. It's not the only country. I think that Russia is also stuck to that approach, and Japan is trying to get on that approach, as well as China. The good and the bad of current reprocessing, one is if you go to the hog site and you visit where they actually put the waste logs, it's kind of an aha moment, because there's a large amount of nuclear waste that's stored in what looks like a basketball court, and it's very clean, it's very safe, it's very stable, and they can stay there for a very long time with very little care and feeding. It just shows you how that can help you manage your storage problem. On the other side is the proliferation concern. Now, no one worries, at least I don't worry about what the French will do with separating plutonium. It just doesn't keep me up at night. It just doesn't, sorry. But I think the concern that people have is, does that set an example for countries that maybe we would have less confidence would handle the plutonium more effectively and safely, and therefore should the highly developed countries, like France and others, continue down that path if we don't want to have some other countries going down that path? And that's the policy level discussion that takes place. So it's not so much, when you hear people complaining about this, it isn't so much that they worry about what the French, the British, and the Japanese are doing. They worry about what other countries might do with a similar technology. The issue with reprocessing from the US standpoint isn't just about non-proliferation, though. It's also about cost. I remember, and this is now 10 years old, so the numbers are probably much bigger. REVA did an estimate for how much it would cost to build a reprocessing plant in the US, and the number was something like $25 to $30 billion. That's a lot of money. And I think it's so much money that without government support, it just isn't going to happen. And I don't think they're ever going to see government support for it. So that's a big factor. So I think that the big challenge for today's reprocessing is the policy environment just isn't right for it. If you have a reprocessing plant and you know how to operate it like France does, it's probably fine to keep operating it, and there's probably a lot of advantages to doing so. But if you don't have one, and you don't have the experience, it's kind of hard to say it's a good idea to start it.
I have two questions. So first is to ensure the secure management of this nuclear technology, the regulatory agency should have some autonomy and independent power. And I think that governance issue is quite first order in developing countries, and I wonder what kind of ways international organizations can assist. So that's my first question. The second question is about terrorism. I think that the nuclear power plant could be a very vulnerable target of terrorist attacks. And are there measures that international agencies are considering to reduce the risk of such attacks?
Let's see. First, let me take the last one first. Particularly in the U.S., but also around the world, security at nuclear power plants is very high. Nuclear power plants are the most heavily protected civilian facilities in existence. They're really, if you visit a nuclear power plant in the U.S., you will see what looks like a small army, a very professional small army that will fend off pretty much anything that comes their way. Airplanes are a different issue. If you're worried about airplane crashes, there's been very, very careful analysis done to look at the vulnerability of specific plants to specific scenarios. And we really convinced ourselves from going through this exercise over a long period of time that the vast majority of nuclear power plants don't have much to be concerned about.
It's not to say it'd be a good day if you did it, but we think that it's a manageable event. And actually the what we call B5B, these are the large diesel-powered pumps that were put in place in nuclear power plants after 9/11. Those were designed to respond to that type of scenario. When you had some kind of attack, like an airplane crash, you could take action and pump water around to make sure that you could respond. And now that's been tripled. There's now 3 such pumps at every plant, and in some plants even more, to respond to a wide range of catastrophes. And this is a lesson based on Fukushima. So terrorism isn't, in my view, I think terrorism is, the beauty of terrorism, if you're a terrorist, is you can launch an attack, be unsuccessful, and still be successful because people, the only thing they will know is the plant was attacked. The fact it wasn't successful probably won't get reported as much. And so so you don't take it lightly, but when it comes from, when you're thinking about it in terms of a large release of radiation, I don't think that terrorism is the way that will happen. And what was your first question? I'm sorry, I forgot.
So regulatory independence from the industry pressure.
Oh, right. Yeah. No, this is a very important question. I think in my member countries, regulatory independence is actually quite high. Some people would say it's too high. As in the U.S., for example, as a commissioner in the U.S. Nuclear Regulatory Commission, I reported to my mom. Basically. I mean that there really was no higher authority, and so the regulatory independence in the U.S. is very, very high. In some countries, it's not quite as high. And in some countries, they've been making changes to try to get it to be higher. In Japan, the regulatory organization was NISA. It reported to the same ministry that promotes nuclear power through METI, and people said, that's a bad idea, let's not do that anymore. So they've now moved it to the Ministry of Environment, which has a different perspective, but some people think that's not even good enough, and so they've been talking about tinkering further with that. Although as a practical matter, the NRA in Japan is very, very independent, and I think has been doing its best under very difficult circumstances. But in developing countries, this is a big problem. In fact, I visited one country that wants to build nuclear power plants, and they're training regulators, and they did. And one regulator, one young person that was on the regulatory staff, asked, so what do you do when the government says we want the plant built tomorrow and we don't think it's safe? So how do we handle that? And we had to talk about that for a while, because if you worry about what the government is saying in terms of meeting a schedule, then you don't have regulatory independence. So I think what we've done and what the IAEA has done is we've highlighted the characteristics of an effective regulator. We have issued 2 documents in the last year or so on this. You can check our website, looking at the characteristics of an effective regulator and the safety culture of an effective regulator. And part of that is to talk about regulatory independence and what that means.
It seems as though it's the bottlenecks or the problems are not technical or money. It's people. You say that mostly all of the accidents, nuclear accidents, are caused by people, by misjudgment. And then the people who are looking at high speed neutrons and all that, and getting a high yield of power out and low byproducts, are all discouraged. And you're saying the people don't trust their government, and yet you say we've got to have more nuclear scientists and engineers, but are they going to be just as timid as the ones that are out there now? I have a feeling that we've got to have a music man like Reagan or Kennedy, something like that, that just does excite people about it. What are we going to get to get the people to realize that this has got to be big and got to be soon. And it's presently small and aiming too low for the climate change problem. And is there anybody trying to put together a leadership site?
Well, there's me, but well, I think I think that your point is well taken. I look at it this way. I think that that when you look at where things are today, you have a situation where in many countries the institutions that are not just in charge of nuclear, but really in charge of a lot of aspects of society and industry, that a lot of these institutions are just simply not trusted. And that's, you know, I think that's, we were actually talking at lunch about this a bit when I was having lunch with some of the students. I think if you look in Europe and even look in the US now, you see the rise of populism. And that's, so this is a bigger issue than just nuclear. This is really a change in society where people are frustrated, people are angry, they don't trust what they're being told by experts and by the government, and they get their news from different sources of the internet instead of the established newspapers. I think we may be in the middle of some kind of flux, a change in the way we do things in our societies, and maybe we're just in an uncomfortable point in time now to get to where we need to get in the future. But I do think that part of the answer to the question, how do you build trust, is by, and this may sound a little PC, but I think we have to diversify our expert base. I think that, and I found this in many venues, when utility executives stand in front of the public, and you have, you have four guys in their 50s with white hair who all look like they graduated from the same high school. That doesn't give people the confidence that this is something that's been well thought out in a way. How do we trust these guys? How do I relate to this person? Poll after poll after poll across the world shows that the most skeptical group of people on the planet when it comes to nuclear power are women. So what we need is more women on that stage, who are not there as spokespersons or facilitators, but there as operators and managers and CEOs to help show that this isn't just a bunch of guys who are playing with technology, but there's people who have families, people who care about the future of the world, and that they are. That they believe this is the right answer. So I think that's a part of it. It's not the whole thing, but I think that's certainly part of it. And I also think that we have to look at our education system, because I think our education system has become a sort of a science and technology free zone in many areas. And so you have a lot of people who are coming out of high school with very, very little technical understanding and very little interest. And so how do you excite people on these technologies when they don't understand what you're talking about? And so I think there's a lot of things happening. I think there are bigger issues. It's not just, and that's something I think is important to have in context. It's not just nuclear. It's really the whole society right now that I think we're dealing with. So it's a challenge. It's a challenge. But I'll do my best to wave the flag.
On that optimistic note, I think we have to wrap up now. We will have some refreshments outside. Thanks everyone for coming, and
Thank you very
please
much.
join me in thanking us.